Okay. See, let's start with amines. Amines in generally we can check out based on how many number of alkyl groups it has. If it has only one alkyl group, we call it as 1-degree amine. Two alkyl groups, you call it as 2-degree amine. Three alkyl groups, 3-degree amine, and so on. Next, in case if the amine has, directly connected with benzene, then we call it as aniline, aminobenzene, or benzenamine, or benzanamine. These are the words that is to be used. And in case if you have, aniline with a methyl group on it, it is called as O-toluidine. If you have two NH2 groups, it is called O-phenylene diamine or benzene 1,2-diamine. The common name for this compound is benzyl because up to this part you can always call it as benzyl, and then there is a functional group amine. So benzylamine. IUPAC name is phenyl methyl methanamine. Phenyl methanamine. A three-membered ring is called as aziridine. A four-membered ring is azitidine. A five-membered ring is known as pyrrolidine. A six-membered ring is called as piperidine. And if you ask me out of this, which one is to be most remembered, I would suggest these three. This compound is derived from pyrrolidine. If I make an aromatic ring within that, it is called as pyrrole. And then if it is coming from a six-membered ring, it's called as pyridine. Okay. And from pyrrole, if you have one nitrogen extra added in there, it is called imidazole. And lastly, if you have the same pyridine with a bicyclo structure, it is called quinacridine. Then we have DAPCO and quinoline, so many different compounds. Okay. But like I said, these three are supposedly most used ones. Next thing, if at all we need to find out how many number of isomeric amines are present for a particular compound, C4H11N. Okay. So you can see one, two, three, four carbons, one nitrogen. So you can see it is primary amine. And you can make four different primary amines with changing the alkyl group's positions. We can make two, in fact, three secondary amine and one tertiary amine. And when we make the primary amine, you can see here it is a chiral center. So total number of isomers include 9. Correct? These are the stereoisomers. Okay, beta. Next. If a question is given like this, C7H9N, and you're supposed to find out how many benzenoid forms we have. That means first you need to use 6 carbons, make a benzene, and then you need to start moving around NH2. So since total we have only 7 carbons, one, we can keep moving that at ortho, meta, and para position. So we can get three different isomers. We can directly connect with the nitrogen to get this as a secondary amine, or you can connect between the benzene and amine, you'll get primary amine. So this way we can get total 5 structural isomers. Okay, beta. Right. This is one simple area that you need to revise from GOC or isomerism, as in how to figure out number of structural isomers or how to figure out number of stereoisomers. Next, let's talk about preparation reactions. First, let me tell you about regular reactions and then I'll come back. If it comes to simple amines, we can always get it from Gabriel thalamide synthesis. This is one of the best methods to get primary amines. If the object is only to get primary amines, then this method is the best. How does it happen? See, this is called thalamide. Phthalimide is something which is derived from phthalic acid, like this. We have a phthalic acid, and phthalic acid, if you react with ammonia and heat it very strongly, okay. So take 2 moles of ammonia and heat it very strongly, then you will end up getting this as phthalimide. That when you react with OH minus, it can extract H plus, generates a negative charge on nitrogen. And this is a nucleophile which will attack on alkyl halides, removing this X, thus getting an R substituted or alkyl substituted phthalimide. Thereafter, as you start pushing more base into it, OH minus can attack, this bond can break, carbon nitrogen bond can break. And again, this N minus can take H plus, you can get NHR. OH minus can again attack here, break this bond here. So that will give you RNH minus, and finally, that will give you primary amine. Clear? Okay. So that's how you get a primary amine form. Now, if you come across phthalimide, NH2, NH2, hydrazine will start attacking from one nitrogen from here, the other nitrogen from here, and that will break this nitrogen form into RH minus, which will take H plus to finally get into primary amine. Okay. So have you noticed this is one of the best preparations for primary amines because there is no other form of amines which is forming. Only 1 degree amines will form. You will not get like 2 degree or 3 degree and so on. There is a lot of advantage in this. In fact, when you have a phthalimide ion that can attack on a carbon which has a good leaving group like chlorine, as it attacks and leaves, you will get to know that you will have nitrogen attached with CH2COOET. And this on hydrolysis will give you, you know, this is an ester, right? Ester will undergo hydrolysis to get an acid, which on further hydrolysis will convert into phthalic acid, and this nitrogen will end up getting as amine form. So what we get is an alpha amino acid. Clear?
Yes, sir. Um, so can I just come in 2 minutes?
Sure, beta.
Hi, sir.
Ah, beta.
Today there's a lot of running around.
Mm-hmm. You are running around.
Yeah. So I was supposed to make dinner today, so I just made that, and then I had dinner. Then I
So
went to
it was your turn today.
yeah.
Okay. Today it was my turn too. Mm, good, good. Okay, let's go ahead. See, how do we get to do the preparations of anilines? What we discussed was about simple primary amines. Okay. Now, in fact, yeah, sorry. For simple amines, I suddenly got distracted here. Check it out. Another method for simple amines is Hoffman ammonolysis. That is, if I take an alkyl halide and then react with ammonia, so the ammonia can attack, halogen can leave, and you'll get RNH2. Okay. This can keep happening as long as there is an alkyl halide available, because this can again act like a nucleophile, attacks here, remove this X minus, you'll get secondary amine, thereby third, tertiary, and quaternary amine, ammonium salt. Now, which one will be major? That depends upon what is the content you are taking in excess. Suppose if you are taking alkyl halide in excess, then you will get quaternary ammonium salt as the major part. While if you take ammonia as excess, then you will get primary amine as the major product. Clear, beta?
Okay.
Right. So notice this. If you have a 3-degree alkyl halide and you react with ammonia, remove this chlorine and hydrogen here, you'll get a double bond. That's how you'll get an alkane. Okay. So because here SN2 attack is not possible, usually E2 elimination is more favorable. And internally, if you have a lone pair, that lone pair itself can attack, remove this bromine. That's how the nucleophilic substitution can take place. Similarly, CH3NH2, the lone pair can attack here, remove bromine. And again, the same lone pair can attack here, remove bromine. So you will get a 5-membered ring here. In case if you have NaN3, okay, NaN3, that is alkyl halide, will first make this N3 to attack, X minus will leave. N3 is a good nucleophile, which you call it as azide. This is azide, okay? And this azide, when you react with lithium aluminum hydride, it will leave away N2 and reduce the part. See, it is very good leaving group here. You can see it is a good leaving group. So this N minus can take the hydrogens as many as possible to remove this part so that it can convert into RNH2. Okay, beta.
Yeah.
And lastly, if you notice the reaction here, so any form of nitro compounds here, correct? If you have a good reducing agent, it will easily be converting into RNH2. Clear? Even if you have R and double bond O also, any bit of reducing agents, okay, it will convert into RNH2. Even if you have RNHOH also, hydroxyl amine also, with reducing agents, it will convert into RNH2. Now the question is, which are those reducing agents? See, reducing agents which does this job includes lithium aluminum hydride, H2 by platinum, palladium, or nickel. We can use um, where is it? Yeah, Raney nickel. We can use this as Raney nickel. We can use red phosphorus plus Hi. So you can see these are all excellent reducing agents which can convert any form of nitro into this. Okay. In
Okay.
fact, especially if your question is only from nitro or nitroso towards any form of amine, you can also get this from metals in acidic medium. Okay, iron in HCl, zinc in concentrated HCl, tin in concentrated HCl. Even they can be used as a better reducing agents. All of them will push them to form amines. Okay, beta? Now,
Yeah.
Let me come back to this compound now, since I'm discussing about nitro compounds.
Mm.
Now, how does this same nitro compact impact if it is with a benzene? So it will become nitrobenzene. H2 by Pt palladium, no problem. Reduction takes place. Tin HCl, no problem. Iron HCl, no problem. Okay. Zinc HCl, no problem. When is the problem? Problem is only with these cases. When you have lithium aluminum hydride. In case of lithium aluminum hydride, instead of giving complete amine, it would be observed. I mean, it is been observed to give more of this one. Okay. Here, this would be more of azobenzene form. Understood? Same way, if we have zinc with NH4Cl, okay, if it's a neutral form, then it will be hydroxylamine. Got it? And if it is zinc in NaOH in a basic medium, then it will hydroazobenzene. This is hydroazobenzene. Clear?
Yes, sir.
So these are few difference which we notice because normally these three are pretty different than the other ones. Okay. And this only happens on a benzene case. Okay.
Okay.
Mm, right. Check out. The simple amines I told you, which are all the reducing agents to be taken. Now, this one becomes very important reaction as well, known as selective reduction, specifically on benzene. On benzene, if you have NO2 groups, in fact, if you have multiple NO2 groups, you know, one of the NO2 groups will get easily reduced. So between these two NO2 groups, you can see this NO2 group will get easily reduced. Clear?
Yes, sir.
So that NO2 group will become NH2 here. Okay. For that, we require only one thing, that is sulfide salts, S2 minus salts. So as long as you have S2 minus salts, the NO2 group present will convert into NH2 group. Done?
Yeah.
Right. These are few questions to revise from what you have learned from hydrocarbons. Correct? And
Yeah.
hydrocarbons and benzene, and how it is been well connected towards amines. Okay.
Okay.
Now, coming to the preparation of anilines. So if you have a chlorobenzene, in case if at all I try to react with ammonia directly, no reaction will take place. But if you take the same ammonia in the presence of Cu2O, okay, at high temperature and pressure, in that case, NH2 can attack, Cl can leave, right? And this will become
Mm.
NH2. But the mechanism is not that easy. It will happen via benzyne mechanism. How does it operate? It is like this. Ammonia will react with Cu2O. It will convert into NH2 minus, and this Cu2O will come Cu2OH twice. Now this NH2 minus is in fact, a strong base. So this NH2 minus will take H plus, pushes to make it as a triple bond, leaving behind Cl, leaving Cl minus. So this triple bonded form, what you will get is called as benzyne. Got it? This is
Yes,
what
sir.
is called as benzyne. Clear?
Yes, sir.
And once you get a benzyne, NH2 minus will attack, pi bond will shift. You get this minus charge. That minus will take H plus from ammonia and you'll get aniline. Clear?
Yes, sir.
Next, you see chlorobenzene. If you have chlorobenzene, react with NaNH2 in the presence of NH3. So we will have NH2 minus taking away this H plus. then Cl will go away, you'll get a triple bond. Thereafter, again NH2 minus will attack via benzene mechanism, you will get aniline form. We learned this that if you have an aryl halides with strong withdrawing groups like nitro at ortho or para position, in that case, directly ammonia can attack, Cl can leave. This mechanism is called SNAR, that is nucleophilic substitution on aromatic ring, or also called as ARSN2 mechanism.
Okay.
Same way, the lone pair present on this nitrogen can also attack, remove this chlorine, and you'll get this product. Okay. Yeah, beta.
Yes, sir.
Right. This is about preparation of amines. Now, when it comes to properties, the first thing we need to check out in amines is its basic strength. Let's say, why do we use the word ammonia? You know, uh, in fact, why are we mentioning that ammonia with a base is because of the presence of the lone pair on nitrogen. That can be used as a Lewis base, which can extract the proton and converts itself into a conjugate acid. Okay. The strength of the amine, the strength of this amine is directly correlated with the stability of the conjugate acid. Okay. If the
Okay.
conjugate acid is more stable, we can say this is a stronger base.
Hmm.
Okay. So that's why if a base is more, that means Kb value is more, pKb value is less, basic strength is more. pKa of conjugate acid is more, which means it is a weak acid, which means it is stable. That
Hmm.
also mentions it is a strong base. Okay. So
Yes.
your entire focus should be about stabilizing conjugate acid, or any factor that stabilizes conjugate acid will increase the basic character of its amine. Okay. Now, if you notice, plus I plus M always increases the basic strength. The plus I and plus M will always increases the basic strength.
Hmm.
Clear?
Yes, sir.
While if it comes to hybridization on nitrogen, you will see nitrogen with sp3, nitrogen with sp2, and nitrogen with sp. If you compare these three, the nitrogen with sp3 will always have more basic character than nitrogen with sp2 and nitrogen with sp. So this is the order in which the basic strength will vary. Okay.
Okay.
Next, if you are comparing two nitrogens of a similar hybridization, here also it is sp3, here also it is sp3. In that case, you are supposed to consider which of them has localized electrons, which of them has delocalized electrons. And you would see this nitrogen's lone pair is delocalized, while this nitrogen's lone pair is localized. So which makes the localized electrons are more basic. Next, you may have delocalized versus localized. With this particular type of delocalization is an extreme form of delocalization because it is a part of an aromatic ring. Because only the movement of that pi bond will make that ring aromatic. Because of which it is extremely poor base. So pyrrole are very, very poor bases as compared to that of piperidines.
Hmm.
Clear, beta?
Yeah.
So these are factors that determine their basic strength. Okay. Now, when it comes to aqueous solution, the solvation will always compete with the inductive effect for stability. In simple terms,
Hmm.
okay. Suppose I have ammonia. Ammonia, its conjugate acid is becoming NH4 plus. Hmm? Okay.
Yeah.
Once it becomes NH4 plus, you can see there are four, you know, uh,
Hydrogens.
strong delta positive charge hydrogens on it. Correct.
Hmm.
So water will immediately come and start making hydrogen bonding with those hydrogens. And this ability to start making a hydrogen bond around it is called as hydration or solvation. Okay, because water is a solvent, we call it as solvation.
Okay.
So there are no donating groups to stabilize the positive charge via inductive effect here. That's why there are no donating groups here, but there is definitely strong hydrogen bonding which is trying to stabilize this positive charge, correct?
Okay.
So both factors will help actually. Inductive effect, if there is any donating group, that also helps the stability. Or if there is a solvation, that also helps the stability. Okay.
Yeah.
Now you would notice that when it comes to solvation, correct? So that means if you have more amount of solvation, which means that is also going to be more stable, or it means it will increase the basic character of it, isn't it?
Yeah.
But as the methyl keeps growing, suppose in this same structure, I have one hydrogen is being replaced by methyl. Okay. Suppose if one of the hydrogen is being now replaced with methyl here. So as soon as I keep methyl here, now it will show plus I effect, but there is no hydrogen bonding here anymore. So there is no hydrogen bonding. So what happened?
Mm.
Hydrogen bonding decreased. That means solvation decreased, slowly plus I increased. And every time there is a plus I increasing, there is a solvation decreasing, correct?
Yeah.
So both cannot offer the same stability at the same time. If one is
Mm.
giving plus I, consequently its solvation will have to decrease. Okay, that's why both of them are opposite. I mean, indirectly proportional to each other. Hmm? Hence, only experimentally we can identify which can have more dominancy. Okay, and if I compare regular amines, especially if you have a methyl amines, we notice that 2-degree methylamine definitely have more edge over 1 degree, then 3 degree, and lastly 0 degree. Okay. So 2, 1, 3, 0. This is the order of solvation. Sorry, basic character. Okay.
Yeah.
So two,
Okay.
1, 3, 0. Next, C2H5. If you have C2H5, correct, then it is 2, 3, 1, 0. This is the order in which it is present. Clear?
Yes, sir.
Next, see. In aqueous solution, overall, this is the order in which you have to identify. So you can see diethylamine, triethylamine, dimethylamine, ethylamine, methylamine, trimethylamine. Then here it is PHCH2. This is benzylamine. It is still localized. Ammonia still localized. From here it is delocalized, you see. So all localized are first, then delocalization is next. And here it is delocalized. Here also it is delocalized. Okay.
Okay.
So this is a complete order given in NCRT as well. So I think you should be able to figure out. Okay. Mm,
Yeah.
right. Next. Check out. If you have to compare the basic strength of the following, clear? Check out CBAD. This is the part we just learned. This is in non-polar. Why non-polar? See, non-polar, there is no solvation. It's not like water molecule is present which will make a hydrogen bonding, correct? So nothing
Mm.
of that sort. So therefore, neither non-polar, I mean, either non-polar or gaseous state, both will have only consideration of plus I effect. Okay,
Okay.
clear? Both will only have consideration of plus I effect. There is no solvation here. So if you compare only plus I effect, which one is better, beta? This one. So C, B, A, D. That is the order.
Mm.
Okay, no? Same way here, you can see C, B, A, D. This is in gaseous state. Understood?
Yes, sir.
Right. Check out these four cases. Here we just discussed it already. This is delocalize, 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 and this is localize. So since it is localized, that has the most basic character. So D, then this has two plus psi
Hmm.
effect. So C, then one plus psi effect. There is nothing. So D, C, B, A. Okay.
Okay.
So like this, you should be able to figure out that, which of them being more or less. Okay. Hmm.
Okay.
Next. Now, if you compare this A, B, C here, this is delocalized. But here you notice that when you have C double bond O NH2, this delocalization is extremely, uh, you know, in fact, very highly enriched towards oxygen, which means
Okay.
it will most of the time exist like this. So lone pair is hardly available on nitrogen, understood? So much
Acha.
so that its hybridization almost becomes sp2 only, correct?
Hmm.
That's why amides are always least basic compared to any form of amines. That's why this amine is better than amides, and cyanides are the worst because it is sp hybridized nitrogen. So that is the
Hmm.
worst in terms of basic character. So C, B, A. That should be the order. Okay, Vita?
Yeah.
Now there are total 20 questions in it. So you need to go through all of them and discuss, go through it once. I just give you a glimpse of it from
Yeah.
GOC, correct? So these are all already there in GOC. In case if you wanted to revise it again, just go through them. Okay.
Okay.
Now let's move into the properties of amines. Amines are usually fishy ordered. Okay. Aryl
Okay.
or aniline are usually colorless, but they get color due to oxidation in atmosphere. Okay.
Hmm.
Lower alkyl amines are soluble in water and higher amines are insoluble. Okay. Lower as in
Um,
mostly methyl, ethyl, propyl, not more than that. Hmm?
so they get colored due to oxidation is that they turn yellowish, right?
Yes, Vita.
Okay.
Okay. Hmm.
Yeah.
Next. We have 1 degree, 2 degree will have intermolecular hydrogen bonding, but 3 degree does not have any hydrogen bonding. Hence, 1 degree, 2 degree usually have higher boiling point than 3 degree. So you can see RNH2 1 degree will be greater than 2 degree than 3 degree. Okay.
Hmm.
If you compare the considerable or comparable molar masses of the various functional groups, so in that case, you will notice this is the order in which it is present. Okay.
Okay.
Clear? Right.
Yes.
Next. Now let's notice chemical reactions. See, first chemical reaction, it's more like an application in amines. See,
Hmm.
suppose if I take amines, add it with HX, it is like an acid-base reaction. Clear?
Yeah.
So you can see it will become RNH3 plus and X minus. This is the salt form.
Hmm.
Okay. And if it is aniline and HX, okay, so you will have anilinium salt, correct? These are the salts you will get. Hmm?
Yeah.
Now, amine salts react with NaOH and that can regenerate a parent amine. So that means this is the ammonium salt reacting with NaOH and OH minus can again take H plus convert back into amine. Correct? Salt bhi ban jayega first, then afterwards when you add NaOH you can get aniline back. This technique can be used in many places. Let me show you how. Suppose I have to separate two insoluble organic compounds, out of which one of them is aniline, the other one is toluene. Hmm?
Hmm.
So what is the best way to do is just react with aqueous HCl. Then the aniline will react with aqueous HCl, convert into anilinium chloride, which is a salt. And
Mm.
this salt get dissolved in water. Okay, so here will be the dissolved form. Clear?
Yeah.
And aniline, now add some ether on top of it. So ether is not dissolved in water. So ether layer will form on the top, and the entire uh, toluene will start mixing up in ether layer. So you can see two distinct layer are observed here, in which this layer will have hold of toluene, and this layer will have hold of anilinium ion.
Mm.
And now by distillation, you can separate these two. So imagine by distillation, we separated these two. Hmm. Now this aqueous solution still has anilinium ion, correct? You add NaOH to it and then add some ether to it. So in the presence of NaOH, this will again convert into aniline. And now aniline is more soluble in ethereal layer. Got it?
Mm.
Understood?
Yes, sir.
Yeah.
Yes, sir.
Right. Check. Next one is acylation. The first application is clear, beta. How just the dissolution of the salt will, make a lot of difference there.
Yes, sir.
Hmm. See, amines, when you react with acid chlorides or anhydrides, okay, it will become RNHC double bond O R. So it is N substituted amide. Okay. See, aniline, when you react with acid chloride in the presence of pyridine, so this pyridine will take away this chlorine along with it. So it will become pyridinium chloride. And
Mm.
this CH3C double bond O will get attached to this nitrogen, thus giving an amide form. Clear?
Yes, sir.
And you see, anilines have very good reactivity with bromine, whether it is in bromine water or whether it is in bromine in non-polar solvent. Because of its extremely strong donating nature and activating benzene ring, it can process the electrophilic aromatic substitution, that is EAS reaction, in both water as well as CS2 to get 2,4,6 tribromoaniline. And 2,4,6 tribromoaniline is white color PPT.
Okay.
Correct?
Yes, sir.
Right. Next. If you have CH3C double bond of Cl, right? So the lone pair can connect, Cl will leave, and you'll get this product. Okay. Now, have you noticed something? This lone pair was making benzene to be highly activated. But now problem with this compound is this lone pair is in resonance with both the sides. So it is this entire group itself, this entire group is mildly activating. So this is moderately activating.
Mm.
Since it is moderately activating, now you cannot have additions like 2,4,6, substitutions like
Yeah.
2,4,6. You will only have one substitution. Let's say that one substitution is at para position here. Okay.
Mm.
And thereafter, again, you add NaOH. This OH minus will attach here. This bond will break. Again, you will get back to NH2. Okay. So, which means here you are not able to control bromine substitution. Here, this is a method to control bromination. Okay. So, if you want only one bromine to be formed, then this is a better method to do.
Okay. Yeah.
Right. Next. Amines react with benzoyl chloride, that is known as, just like we called it as acylation. Now we call it as benzoylization. Okay, it is called benzoylization. Just a minute.
Mm.
Sorry. Right. So see, amines when they react with benzoyl chloride instead of acyl chloride, it is called benzoylization. Okay.
Mm.
Basically, instead of phenyl, if it was CH3, this is called acylation. That's it. Okay.
Mm.
Next, this is an important test in amines, carbyl amine test. Okay, also known as isocyanate test. Basically, it is a detection for presence of 1 degree amine, whether it is alkyl amine or aryl amine.
Mm.
Whether it is alkyl or aryl, both will be present, correct?
Yeah.
And this test is called carbylamine test. Now, what we do here, you take up amine, react with chloroform in the presence of ethanolic KOH. That means you take sufficient amount of KOH there, and this will produce a product called isocyanate. And isocyanate is a very, very foul smelling vapor. And if there
Okay.
is a foul smelling vapor observed, that means there is a carbyl amine test done. Clear?
Mm.
So you can see 1 degree amine react with chloroform in the presence of 3 moles of KOH. It will give you isocyanate.
Okay.
Clear, beta?
Yes, sir.
Done? Clear with carbyl amine test?
Yeah.
Now, carbyl amine test is given by all the forms of primary amines. Any form of primary amine is there, it will give the positive test. See the
Mm.
mechanism. Chloroform is like an acid because of its strong, highly positive hydrogen. So OH minus can take H plus, convert into CCl3.
Mm.
CCl3, because of its structural issues, because carbon having a lone pair with other three chlorines on the same plane, they will repel each other. So these chlorines will repel each other. So because of which it will remain unstable and convert into a carbene form. Okay.
Mm.
Mm, mm. So CCl2 plus Cl minus. Now CCl2 have an empty orbital here. So you can see it has an empty orbital. So this can act like a Lewis acid, and this can act like a Lewis base. So that's how the lone pair from nitrogen will attack CCl2, converts into this form. Because you got an extra electron on carbon, it gets a negative charge. That will take internally H plus from the nitrogen, converts into this form. And because these two chlorines are good leaving groups, the lone pair will keep pushing till the chlorine keeps going away. First time, one chlorine will go. Again, OH minus can take H plus from here. Second time, one more chlorine will go. You'll get this form. Again, OH minus can take H plus from here and end up isocyanate formation. Hmm?
Okay.
Clear it up?
Yes, sir.
Next, check out Hinsberg test. Hinsberg test mainly is used to differentiate 1 degree, 2 degree, and 3 degree amines. Okay.
Okay.
So this is the official test that is used if you want to differentiate or separate. It can be used as separation process also. If you want to separate 1 degree, 2 degree, and 3 degree amines. Let's say, I mean, for that, the reagent used is either benzene sulfonyl chloride
Mm.
or toluene sulfonyl chloride. Okay.
Mm.
Any one of them can be used. There is no problem. Both will give same reaction. Now, let's say I take tosyl chloride, which is toluene sulfonyl chloride, with primary amine. What would happen? Okay. And
Mm.
if you have RNH2 and you have TSCl. So Cl and H can be removed, and I can get this as RNH with TS. This is what I can get. Clear? TS means it is connection with S beta. This is the product you will get like this. So S double bond O, and this is connected to primary amines like this plus HCl. Understood now? This is how the this is RNH and this is TS. Okay. Now this is actually a white precipitate. So it will start becoming a precipitate first. As soon as you react with TSCl, it will become a precipitate. Now that
Hmm.
is where you use the second step. When you add KOH or NaOH, because this has H plus present here on nitrogen with OH minus, it will give the next reaction here, correct? Which is about getting this as negative charge. So you will get this as N minus and R, which dissolves. This will dissolves in aqueous solution. Got it?
Okay.
Yeah.
Yes, sir.
And once you get this get dissolved here, correct?
Hmm.
Again, if you add HCl, the precipitate will come back. This is the same precipitate you will get back. Clear? So what did we notice? Primary amine था पहले पहले white precipitate बना फिर dissolve हो गया फिर white precipitate बन गया. This is the
Oh,
journey of 1 degree amines. Okay,
okay.
beta. If it is 2 degree amine, what would happen? See, if it is 2 degree amine, first you add tosyl chloride. Here also you will get white PPT. Same as this one.
Hmm.
Same as this one, you will get white PPT. Correct? But this time there are no hydrogen present on it. It would only have two R groups on it. So what happens in the presence of OH minus? Now it does not form any dissolved salt. Correct? Now you can see
Oh,
there is no dissolved salt in it. Clear, beta?
yes, sir.
Therefore, because it does not have any dissolved salt, there is no point of adding HCl also. It will remain the same.
Hmm.
And lastly, if it is 3 degree amine, 3 degree amine never forms a precipitate only. Correct? Because
Hmm.
if it is 3 degree amine, it will exist like a salt form only. Uh, like this. S double bond O and N plus and three R groups like this. And Cl minus. Correct? This is the form 3 degree amine will exist. Understood?
Yeah.
So it will only we expect this to remain only as a precipitate form. It will never form some kind of a solution. Correct?
Hmm.
Understood? So therefore, it will always be in a dissolved form only. So since there is a dissolved form, that will be 3 degree amine. So first, between these two, there is a there is a precipitate forming. Here there is no precipitate. So 3 degree separate हो गया बेटा.
Yeah.
And between these two, the minute when you add KOH, this got dissolved. So this got separated. This will remain as a precipitate. So this all also got separated. That's how
Okay.
you use it as a separation process. Okay, clear now?
Yes, sir.
Now similar test can be also done via HNO2, nitrous acid. Okay, what does nitrous acid do? So you have 1 degree amine RNH2. Okay, NaNO2 in HCl. Correct. So this will give us Rn2 plus, and finally Rn2 plus is unstable. It will convert into an alcohol form. So 1 degree amine will release a nitrogen gas. Correct. Okay. Clear. Nitrogen gas is left, and you'll get this into an alcohol form. Clear.
Yes, sir. Yeah.
Mm. If it is about secondary amine, clear, the nitrogen will attack on NO plus, convert
Hmm.
into this yellow oily liquid. Hmm?
Hmm.
Okay. Instead of forming any precipitate here, you'll see a thick yellow color, oily liquid forming, and that
Mm.
confirms the presence of 2-degree amine. Okay, and I told you, remember, Lieberman nitroso test is used in both cases. One is for
Yeah.
phenols, the other one is for secondary amines. This test is called Lieberman nitroso test. Okay. Hmm. Chana clear beta?
Yes, sir.
Right. If it is about 3-degree amines, then R3N will react with NO, but this will remain as a colorless liquid which will easily come back. So again, it is just like in Hinsberg test also, 3-degree
Mm.
amines does not have any product as such. Okay.
Okay.
So 1 degree you can predict as an alcohol, 2 degree you will predict as an yellow oily pigmentation, 3 degree you'll hardly see any reaction happening. Okay, right?
Okay.
Even with 1 degree, if you maintain at a very low temperature, 0 to 5 degrees Celsius, correct, then you will see diazonium salt forming, benzene diazonium salt,
Yeah.
and that slightly on boiling with water will convert into phenol form. Okay,
Okay.
so these are major tests, beta. One is Hinsberg test, the other one is HNO2 test,
Mm.
carbylamine test, and HNO2 test. There could be a question which could be asked like this, that find the number of possible products formed. Like this is an 1 degree amine, NaNO2 HCl is being used. Okay.
Mm.
So here NH2 will convert into N2 plus. N2 plus is a good leaving group. It can leave, generate a carbocation.
Mm.
This carbocation can rearrange into second degree carbocation. And within the solution, see when you have NaNO2, इसमें क्या क्या solution में क्या है? You have water, we have Cl minus, there is small amount of NO2 minus. Okay, correct. And yeah, these are all the reagents which you have here.
Yes, sir.
So if this positive charge attacks on water, you'll get alcohol. Cl minus attacks, you will get this one. Correct. On
Mm.
heating, you will get a double bond. You can get this one. Correct. You can get
Yeah.
nitro substitution. Okay.
Yes, sir.
So you'll get this as nitro group. And if you have something like, alcohol formation already, this lone pair itself can back attack and convert that into an ethers.
Mm.
So there will be small composition of ethers also. Same thing with this 2 degree also, the same questions, same products you can get. Alcohol, chloroalkane, nitroalkane, alkene, and ethers. Cross ethers can also form. Between these two also ethers can form here. So many different products you can observe. Clear? Hmm. Yeah. Same way. Check out CH2, NH2, NaNA2 and HCl. You will get CH3N2 plus. Then we have CH3 plus and N2. CH3 with water gets alcohol, chlorobenzene, chloromethane, and ethers or nitro groups. These are all what we learned. Correct?
Mm.
Same way, in case if you have, here, in case if you have primary amine like this, first you'll get N2 plus. देखो बेटा, N2 plus तो चला जाएगा. This positive charge can directly get these kind of products here, or it can undergo ring compression. Why? Due to ring compression, four-membered becoming three-membered is a very stable ring. Okay,
Mm.
because CPM carbocation is extremely stable form of carbocation. Okay.
Mm.
So this four-membered ring will break, it will form here, and the positive charge will come on this side. Clear?
Okay. Yeah.
CPM carbocation has two resonating structures like this. So that means now if you notice, you have this carbocation, you have
Mm.
this carbocation, you have this carbocation. All three can form various sorry, I lost the connection. See, as soon as you react with water, you will get these type of alcohols. The percentage is important here. You will see around 47 percentage here, 48
Mm.
percentage and 5%. The percentage is not very different here, but still, if the major product is asked, you'll always emphasize this as the major product. Clear?
Okay. So how many pages do we have left now?
What beta?
No, I was just asking how
Another
many.
4 5 pages, I guess.
Okay.
See, from here, mostly reactions are repeated.
Yeah.
Now see, aniline with HNO2 give benzene diazonium salt. With water, you will get phenol. Correct? If it is
Mm.
secondary amine, you will get yellow oil and oil formation, which is Lieberman nitroso test. If it is
Mm.
3 degree, you will get nitro group substituting at para position. Okay, here. Hoffman exhaustive elimination is something which we learned, earlier. Okay, in
Yeah.
alkenes. So wherein the nitrogen will keep on taking as many methyls as possible till it becomes a salt form, less charged. And then when you react with a base like AgOH, this OH minus can extract proton from this beta position, remove this group, and convert into a double bond form. Okay. Same way in this question also exhaustive methylation. Then AgOH take H plus from here or H plus from here, but it would
Mm.
naturally take H plus from the position where you can get Hoffman product. Hoffman is a major product here. So this side double bond will form. So again, if I do the methylation CH3I, the nitrogen will take one more methyl and then remove hydrogen from here, get a double bond here. So this is the product. So this plus nitrogen with three methyl groups on it, like this. This is the product. This is called Hoffman exhaustive elimination. Clear?
Okay.
Hmm. This scope elimination mustard oil test, it is not there. Yeah, mustard oil test was asked in mains once. Okay, let me just go through it.
Mm.
If you have a 1 degree amine, it's specifically for 1 degree only. Okay, 1 degree amine, when you react with CS2 in the presence of HgCl2, correct? The nitrogen will attack on carbon. You will get NC double bond CS2, and then this sulfur will slowly start losing into H2S. Okay, and this H2S is something which will be, reacting with HgCl2 and convert into HGS black. Clear? And this particular, isocyanate which is forming thioisocyanate, that smells like a mustard seeds. That's why. Clear? Hmm.
Yes.
Notice. Check out the azodine now. Okay. If you have aniline react with, you know, uh, this is benzene diazonium form. Now, one thing about benzene diazonium is it can be used as an electrophile because it has a positive charge. Clear?
Mm.
So if you have NH2 with this form here, from the para position, it can attack on the nitrogen, get into this azo dye form, and this azo dye form is yellow. Okay. For this to happen, usually the pH should be maintained at a slightly acidic nature. Okay.
Mm.
If you maintain the basic nature, the reaction will be slow. But if you maintain an acidic form, the reaction would happen better and you'll get this yellow color dye formation.
Mm.
Now, this can be done even with beta naphthol. Beta naphthol with N2, this will give you azo dye, which is red color. Okay. And with phenol, see, with phenol, and we have diazonium salt like this. In this case, we require pH to be slightly basic,
Mm.
and then we can have a azo dye formation here also, N double bond N, and this compound will be formed like this. Okay, clear?
Okay. Also,
And I told you this before also, BPA ROI,
yeah.
right? Clear?
Yes,
So
sir.
this is red, orange, yellow, beta naphthol, phenol, and aniline. Okay, understood? Hmm. Done. Notice. When it comes to aniline plus HCl, you will have anilinium chloride form. Okay.
Mm.
And same way, by chance, if it is with any other acid also, you'll get a salt like this. Okay. And we just learned it already. If you have AC2O, this is called acetylation with bromine water, bromine and CS2, we get white PPT. We learned all of this part just now. One thing we
Mm.
didn't learn is this reaction, nitration and sulfonation. See, if it comes to aniline with concentrated HNO3 and concentrated H2SO4, okay, you can get nitro on ortho, meta, or para positions. Okay. At para position, you will have around 51 percentage, meta around 47, and ortho you'll have only 2 percentage. How come meta is coming? Because NH2 is an OP directing, correct?
Yeah.
And how come meta is coming? It is because you are keeping this reaction in an acidic medium. So first lone pair can take H plus, converts into this NH3 plus, which is a strongly withdrawing group. Okay.
Mm.
Yeah. And because it is withdrawing group, it can activate the meta position. Clear?
Yeah.
At meta position, you can substitute NO2, and that's how you'll get this 47 percentage. Clear?
Yes, sir.
Hmm. Clear? When it comes to sulfonation, beta, from this para position it can attach, but first thing what it can do is it will make an acid base reaction. Hmm? And thereafter, as you heat, this sulfate will come out and reach out on the para position. And when it reaches here, it will be appearing like sulfate has negative charge, ammonium has positive charge. And a molecule, within a molecule, if you have both positive, negative charge present, then it is called a Zwitter ion. Then it is
Okay.
called a Zwitter ion. Clear?
Mm.
And lastly, Friedel-Crafts reactions are not observed with nitro group aniline forms because it is extremely strong donating group. Strong donating groups or strong withdrawing group does not give Friedel-Crafts reactions. Okay.
Yeah.
But by chance, if you have NR2, that means although it is a strong donating group, but there is no hydrogen present on it. Hence, this
Mm.
will give a para substituted group here. Sorry, this is CH3. Okay. And this is what
Okay.
is to be formed. Done?
Yeah.
Clear, beta? That's it. These are all now the doubts. Clear? And
Oh,
as much as chapter is concerned, only this much is what you have. Clear? Mm.
this was pretty short. Like it took an hour.
Yeah, beta, it's a small topic. I told you, right? Mm. The next topic, because it has a lot of repeated reactions only.
Yeah.
One second.